Hello and welcome to our video presentation of our scientific project concerning laser engraving. Our project takes place in a bigger one that is led by a PhD student. His aim is to improve electrochemical batteries. The work is focused on the part between the positive electrodes and the electrolyte, which is made out of yttrium stabilized zirconia, which we call YSZ. First, to avoid oxidation, the layer is put between two elements acting like a barrier. To increase the contact surface between the two, the YSZ must be engraved. We are searching for a structure that looks like a mountain from the side, and that is repeated at the same frequency. This is called ellipse, which stands for laser-induced periodic surface structure, and looks like lines separated with a nanometric distance from a top view. But how can we do that? So, the substrate is engraved in a square shape. However, if we zoom in, we'll see a succession of dots. In fact, the laser delivers impulsion that is engraving dots by dots, and this ends up creating a line, which repeated gives out the square shape. Then, in order to check if we have obtained the wanted structure, we can use a scanning electron microscope, which we'll call SEM. One of the goals of our project is to improve the program that controls the scanning and the way the surface is characterized. The old programs allows to engrave materials according to the shape of an S. It is possible to control the speed in each direction, the length of the engraving, and the space between each line. So what we did is, instead of creating a new program, we kept the one that was already made, but we have added three new shapes. A square spiral that is starting from the outside, a second one that is starting from the inside, and one that is a succession of right angled fitting together. We also changed the program in order to be able to increase the engraving speed automatically every 2 lines. We kept the same user interface of the program and just added a way to choose the engraving acceleration, a way to choose the pattern, and finally a way to parameter the new patterns. Well, once the engraving is done, it is needed to be characterized to see if we have obtained what we wanted. The SEM is yet the only way used. However, it is an expensive and time-consuming way of doing it. The ellipse can be used to create what is called a wire grid polarizer. The idea is to send a polarized beam on the engraved surface. What is wanted is that if the substrate is turning away, the beam should extinguish, meaning that the engraving acts like a wire grid polarizer. This, however, is not a substitute solution, but a new step in order to give a clue whether or not we have the presence of ellipse. By adding a simpler and cheaper test before the SEM, we hopefully can save time and efforts. We hope that our project has given a glimmer of improvement to this research project, and it should be time savior and be helping to finally find the wanted structure more efficiently.